Welcome to Ask and Learn.
Hello students, in this question we are given a cobalt foil. So the diameter of the cobalt foil is 1 centimeter, that is equal to 0.01 meter. Thickness, let's call this H, is equal to 0.0001 meter, that is 0.1 millimeter. Thermal flux phi is equal to 1 to the 10 to the power 11 neutrons per centimeter square per second. And then activation cross section sigma is equal to 36 barns, that is equal to 36 times 10 to the power minus 28 meters square, that is 1 barn is 10 to the power minus 28 meters square. Density of cobalt is given as 8.9 gram per centimeter cube. Duration of irradiation T is equal to 7 days, that is 7 times 24 times 60 times 60 seconds. So first you can calculate the volume of the cobalt. So volume is equal to pi times d by 2 the whole square times h, that is the volume of the cylinder. So that will give you pi times 0.01 divided by 2 the whole square times 0.0001. So you will get volume will be approximately equal to 7.85 times 10 to the power minus 9 meter cube. That is the volume, right? That is the volume. Now let's calculate the number of cobalt nuclei in cobalt foil. So number of nuclei can be found out using this equation, rho v by molar mass. So that will give you density, which is given as 8.9 times 7.85 times 10 to the power minus 9. So this is gram per centimeter cube, right? We need to convert that into kilogram per meter cube. You can multiply by 10 to the power 3 and you get kilogram per meter cube divided by the molar mass. So the molar mass is given as 558.93 gram per mole. Okay. So here there is a ratio, so we can skip this. We can just skip this and this ratio will cancel each other. This gram will cancel each other. So that will be easier. So you get N will be equal to 1.818 times 10 to the power 16 nuclei. Now let's calculate the number of cobalt nuclei activated by neutron flux. Number of activated cobalt will be equal to the flux phi times sigma times T times N act, right? So that will be equal to flux is 10 to the power 11 times 36 times 10 to the power minus 28 times 7 times 24 times 60 times 60 times N act is equal to 1.18 times 10 to the power 16. So you will get the flux value will be equal to so the activation number of cobalt nuclei activated by neutron will be equal to N act will be equal to 1.28 times 10 to the power uh, sorry 2.57 times 10 to the power minus 6, that is the number of nuclei required. Sorry, plus 6 nuclei, that is the number, positive number nuclei required. Now let's calculate the activity in becquerels. So activity A will be equal to lambda N act. So lambda dk, which is the decay constant for cobalt. So you can use the half-life equation to find that out. So T half is equal to log 2 by lambda. So lambda will be equal to log 2 by T half. So T half for cobalt 60 is 5.27 ES. So A will be equal to lambda, which is log 2 by 5.27 times 365.25 times 24 times 60 times 60, right, times n act. So n act here we have found out. So that is equal to, so times 2.57 times 10 to the power 6. So uh, the activity will be equal to in becquerels, it will be equal to 1.071 times 10 to the power minus 2 becquerels. So you can multiply to find out in microcuries. You can multiply becquerel into, so activity will be equal to 1.071 times 10 to the power minus 2 times you multiply it with 2.7 times 10 to the power minus 11 to convert it into microcuries. So you will get activity will be equal to 2.89 times 10 to the power minus 13 microcurie. So that is the solution. I hope you find the solution useful. We have found out the activity. So I hope you find the solution useful. Thank you.